Hey y'all, sorry I'm not here. I think I've got one more day without you, and then I'm coming back. You guys are groaning. Oh God, not that guy again. So we're checking out 6 factoring, and you can put that at the top of your notes. We're using this form ax2+bx+c with a's and b's and c's. It's gonna be great. So buckle in. Try this as a warm up. Factor this piece. Factor this piece, think about pulling out a common term, etc., etc. Yeah, go. Okay, here we go. So if you pulled out a common term, you pulled out a 2 out of this, you're left with 2x, and you pulled a 2 out of that, that's 6, you pulled a 2 out of that, that's 8, right? This will give you 2x, 12, and 8. And so then this would factor, the 2 sits out front because it's 2 times this, and this is really binomial times binomial. It's an x and what, a 2 and a 4 or something like that. Pluses, ka-ching, ka-ching, and if we're lucky, yay, great. Switch the order, it doesn't really matter. If you do that with this, that guy's almost as weird looking as me. If you do that with this, if you pull a 2 out front, you get x squared. But then here you get 6.5 or 11 halves x, and here you get 6. You can factor that, but it's awful, right? So this factors into this thing. And so what we're going to learn how to do is, without pulling this term out, take this mess and turn it into this nice factored form, because this is the factored form. Ka-ching, ka-ching. If you look at this, if you dump this into here, you get 2x squared. Ka-ching, you get 12. Ka-ching, and you get 8x, and 3 more x's, 8, 9, 10, 11. And that's this piece. So this works, but we're going to figure out how to go from trinomial that doesn't have common factors to pull out, ax squared plus bx plus c, and turn it into nicely factored form so we can vanquish our opponents. All right. So learning outcomes, we're going to factor those, right? Once we've pulled out all the common terms, right? And the practicants. Here we go. So sometimes we can't pull those things, a common term out, but it doesn't mean we can't factor it. Yeah. So there aren't generally things that are completely unfactorable yet. We may find things that don't work as well later on, but. So let's figure out how to do this by sort of reverse engineering. Yeah. So if we take something with an a term here, 3x plus 2 and 2x plus 5, and you multiplied these in. We're working backwards, right? So if you multiply these in, oh, there's fancy things here. This would turn into this piece. Yeah, you get this 6x squared. You get 15x, 4 more x, and 10. And if you combine those, the 15 and the 4 give you this 19. Cool? So really, these pieces give you the 6. These pieces give you the 10. And this guy, this 19, is sort of a sum of the inner products, right? It's these two multiplied together. And so each of these pieces comes from here, right? And the big giveaways are going to be the firsts and the lasts. So we're going to really look at this piece and this piece initially, and then sort of fuss with this middle piece until it's right. We'll do a couple problems. I know it's kind of overwhelming at first, but we'll do a couple problems that'll go like butter. So let's try this out. Let's keep moving. The first way to do this is just sort of try it out, guess and check. This is back to our original warm-up problem. I know that whatever this piece comes from this chunk and this chunk multiplied together. And so really, I know it's got to be something x times something x to give me the x squared. And what's the only way to multiply to 2? Well, this is 2 times 1, right? So I'm going to put a 2 there and a 1 there. I guess you don't really need the 1, but So if we were to distribute these, you get, this is a little bit broken up, so this is like 2x plus who knows what times 1x plus who knows what. And if you multiply those back together, you get this 2x squared. That works. Right? This piece, oh, thanks, I needed that. Oh, good. Spinny wheel of death. Thanks, great. This middle piece, or sorry, the end piece right here, that comes from this chunk and this chunk. And there's a couple of ways to multiply to 12. You can get 1 times 12. So you could do 12 and 1, or 1 and 12. You could also do 3 times 4. You could do 2 times 6. I'm just kind of laying out all the things that it could be. I'm looking to make these two multiply to 12, but then once you put them all together, I want them all to add to this 11x. So I'm just going to try something. This is a guess and check method. So I'm just going to pick maybe this 3 and 4 first. It's guessing, so I'm going to guess. So I'm going to put the 3 here and the 4 here, right? Maybe in a cleaned up form, it'd look like that, right? The 3 there and the 4 there. And so really you have this mess, and if we tried it out, if we tried to distribute it, you'd get 2x squared. Yup, so that's this part. Man, that's a lot of mess up there. Jeez. Clean it up a little bit. There we go. So if we multiplied this 2x and x, you'd get 2x squared. That works. If you multiplied 3 and 4, you get 12. But let's try to the middle parts. We get 8x here by multiplying those, and 9, 10, 11x. So I guess this is 3 more x. So then we get 11x here, right? And so I guessed the first one right. I've just done a lot of them, right? It's nothing special. This isn't like a great way to do it. Eventually, it's what you'll be doing, but there's a more systematic approach, and that's what we want to try out. And so that's this same equation, same trinomial that I'm trying to factor. I want to find all the factors of 2. So what are all the ways we can multiply to 2? Well, it's only 1 and 2, right? So those are all the ways we can multiply to 2. What are all the ways we can multiply to 12? Well, first we can do 1 and 12, and we can multiply 12 and 1. So some people like to put this sort of grid together. And if you multiply the outer and the inner pieces, then you'd get 12 times 1, that gives you 14. That's not what we're looking for. You get 25 with 1 and 12. That's not what we're looking for. What we're doing here is this, right? You go 1 and 2. That's this piece. And this piece is if we went 1 and 12. And so we're getting the 14 from saying 12x plus 2 more x is 14x. And then this one's like, oh, okay, well, maybe we just put them in the wrong spot. So let's move these. It was 1 and 12. Let's make it 12 and 1. So now this is 12 and 1. And so now this is 1 and 1x and 24x. So that's 25x, right? And that's not what we're looking for. So this is not a lot better than guess and check. Oh, good, again. This is not a lot better than guess and check, but it's at least systematic, so you know that you've exhausted all your efforts, right? So let's keep going. Let's try 2 and 6. Well, if we put 2 and a 6 here, a 2 and a 6, this would be 6x and 4 more x, so 10x, not what we're looking for. And if we keep doing that, right, we try all the different combinations in different orders, right? We're swapping them around. 2 and 6, 6 and 2, 3 and 4, 4 and 3. Eventually, we find one where once we multiply, once we do the right order, we say 4 and 3. This is 3x and 8x, and 3 and 8 is 11. Ka-ching, and that's what we want. Ka-ching. So this is our factored form is 4 plus x, sorry, x plus 4, that's this, times 2x plus 3. Right? So that's kind of heavy to like absorb the first time. So let's try a couple. If you think you are comfy with it, just pause me and roll. Yeah, try them out. I'll pop up these and the answers, and we'll and just keep going. If you want to work through a couple with me, all you'll need to do is a handful of them, and you'll be like, all right, let's go. So pause me, try them, and see how we do. All right, so here's the answers for these. Ba-bam, ba-bam. Let's try to see where they came from if you're not quite sure. Just roll with me on them. I know this thing is going to break into a binomial, right? I know that it's going to end up being a plus and a plus because of these things. And so I know that these first terms here and here are going to have to multiply to 2x squared. The only way to do that is to say one of them be 2x and the other be x. The order doesn't matter right now. Great, fine, right? 2x times x gives me 2x squared. I want to do the same thing with this last term, but I know that this and this have to multiply to 21. Well, there's 21 and 1, and there's also 3 and 7, or 7 and 3, right? They can switch back and forth. And I don't know which one they are, but generally it's sort of the middle one. So I'm gonna try 3 and 7 in this order because I don't really know. I just want to see how it goes. So yeah, 3 and 7 will multiply to 21. But let's see what happens when we multiply this times this. You get what? 14. And here we get 3 and x. So, oh, great. So that was 14x, and here we get 3 more x. 3 more x, and that gives us 17. So we got it on the first try by, well, I picked this one because I have enough experience to say, usually the middle ones work out the best. Since this isn't a very big or a very small number, I just picked that one, and I happen to have written them down in the right order. If I didn't write them down in the right order, and I put them in as 7 and 3, this piece would be different. It would be 2 times 3, I'm going to write it in red, 2 times 3 would give us 6x, and 7 times x would give us 7x. And that's not the 17 we're looking for, right? So this way doesn't work. So then all I would do is take these and flip them and say, okay, let's try 3 and 7. And we'd get this piece, and we'd say, hey, that does work. That is 17x, right? Ka-ching! So we end up having 2x plus 3 and 7 plus x. Cool? If you didn't get that before and now can walk through that with me, try this one, pause me, and see if you can make this out of it. And if not, we'll come back together in a second. Okay, so this we know is going to be a binomial. 2 binomials multiplied. They're both positive, so these are both going to be positive. This is a little bit trickier because 6x, you can multiply it to 6 by going 6 times 1 or 2 times 3. I don't know which one it is, so I'm going to try 2x and 3x. Also, 4, you can also make 4 by saying 4 times 1 or 2 times 2. And I don't know which one of those are. So I generally pick the middle and the middle rather than the extremes, right? So I'm going to try, here's my 2 times 3 right here, 2 times 3. And here's my 2 times 2. I'm going to try 2 times 2 and just see if this works. So this 2x and 3x, yeah, that's the 6x squared. This 2 times 2, yeah, that's my 4. It's the middle term. Oh, this should have an x on it. What was I thinking? Should have an x on it. Why didn't you guys say something earlier? So now let's try the middle stuff. This is 4x, and this is 6x. So that's 10x, and that's not 11x. Quack. So 2 and 2, oh, that's kind of nice because 2 and 2 doesn't work. So I know this one doesn't work with the 2 and the 3. I'm going to, just for trial and error sake, try the 4 and the 1. Right, so let's try the 4 and the 1. Here's a 4, here's a 1. Let's see if this gets us any closer. This is 2x, and this is 12x, and that's 14x. That's not what we're looking for. Let's just switch them. See, there was 4 and 1. Let's do 1 and 4. 1 and 4. This one didn't work. So this is 8, right? This is 8x, and this is 3 more, which is 11, 8, 9, 10, 11. Yeah? So that works. That's the 11x we're looking for. So here's our 2x plus 1, that's this piece, and here's our 3x plus 4, that's this piece, and we got it. Now, if this didn't work, what we could say is we've tried all the options with 2 and 3. Scratch 2 and 3, and now we go on to, we might have to, well, I guess we switch 2 and 3 by switching these. Then we go on to 6 and 1, and we do 6 and 1 with 2 and 2. We do 6 and 1 with 4 and 1. We do 6 and 1 with 1 and 4. And one of those is going to work, provided you don't freak out and give up. All right, so, I mean, it's basically the same thing as the systematic. This is the same thing applies when you have negatives and positives. There's little bits of hiccups. The only thing is, if this is positive and this is negative, these are both going to be negative, because you can multiply to positive 8 by negative 2 and negative 4, or positive 2 and positive 4. Right? They'll both give you 8. The only way you get negative 8 is if one of these was negative and one of them is positive. Right? So you can look at the signs on this. You're going to do the same thing, except the signs give away what the signs inside the binomials are going to be. So here's an example. We have 5x squared and 8. I know that 5x, the only way to do that is a 1 and a 5. Great, so I know that this is going to be x and 5x. And 8 we can multiply by 1 and 8 or 2 and 4. I'm going to guess right off the bat that it's 2 and 4, and so I'm going to put these in here anyway. Doesn't matter. You might get it right, you might not. But if you look at these signs, this says I multiplied these two and got 8. It could either be positive and positive, and that would give us 8, but this is a negative x value, and there's no way you're going to get negatives by these being positive. So what this gives away, right, if you put your nerd goggles on, is that both of these are negative, because you go negative 4 times negative 2, you get positive 8, and if they're both negative, then they'll give us a negative b term. Now, it doesn't mean that these 4 and 2 are right and in the right spot, but it does tell us that the signs are right. So let's give it a shot and see if we can get this right. I'm guessing from this thing that we don't have it right, but I'm going to pretend that it's not there. Right? This is 5x squared, ching. This is 8, ching. This is negative 2x here, and this is negative 20x. Right? And that's negative 22x, which is not this. So this is not right. So what we're going to do is just, this was 4 and 2, let's make it 2 and 4 and see if it works. All right, 2, let's go 2 and 4, and try her again. Right? We really don't have to check this and this again, but it's 5x squared, yes. Positive 8, yes. And this piece is negative 4x minus 10 more x. And that's the negative 14 we're looking for. Right? So if you were to distribute this completely, you'd get 5x squared, negative 4x, this piece, negative 10x, this piece, and negative 2 times negative 4 gave you the positive 8. And then if you crunch these together, you get negative 14x. And that would be what we're looking for. So this works for us. equal. Try this one, aim for this one. Same things apply. They're both going to be negative here. To get a positive, if this guy's negative and this guy's positive, they're both going to be negative values. So try this out, see if you can get that. Same sort of thing. You can do this in a systematic format where you say, here's all the factors of 4. 1 and 4, 1 and 4, 1 and 4. They should have done 2 and 2. Here's all the factors of 2, and here's the inner and outer, and like building a table, right? Maybe you like those tables. Maybe they annoy you. But it's the same sort of thing. You figure out that this 4 and y gives you the 4y and y gives you 4y squared. The -1 and the 2 give you this -2, and this sign gave it away because one has to be positive and one has to be negative, and it's a little bit fussy there, right? But you'll notice that the bigger, this gives us the 8y, and that's bigger than the -1y, and that's why we still have a positive value here. So just like when there was a common term, sometimes we can factor out a -1, so sometimes there's a negative in each term, and you just pull it out as a -1 and then factor this piece. That's another way to do it when you see negatives all in the same spot, and that helps you not have as many negatives to attack. So this is sort of your trial by fire. Try these with sort of a messy negatives and positives sign, and we'll come together in a second. I'll do them with you, and we'll go from there. All right. This, right off the bat, I know that this has to be 3 and 1 because there's only one way to multiply to 3. I also know that this is negative, so one of them has to be positive, one of them has to be negative, but I don't really know which. So there's going to be a lot of guessing and checking going on. This could be 6 and 1, or it could be 3 and 2. I'm going to start guessing with the 3 and the 2 because they're more average values. So this is going to be 3x and 2x. I don't know that for sure, and I don't know the signs for sure, so I'm just trying to see how they fit in. But I know that this tells me that one is going to be positive and one is going to be negative. That's the only way that we multiply to -3. But I know that overall, the bigger value of the two, like when we do this and this, the bigger one is going to be on the positive side. So let's see, this would give us 3 and this would give us 6. So I'm guessing it would have to be like this because the 6 would give us a bigger number than this. Let's try it out. This gives us this 6x squared. This does give us -3, so that's okay, right? 6x squared, and this is -3. Oh, I don't know what happened over there. And then this would give us -3x and 6x plus 6x. And if we add those up, that's 3x and not 7x. So that's not the way we want it. Let's, before we do anything, just switch the signs, right? Well, let's see if we need to switch the signs. This gives us a smaller value than we wanted, right? It gave us 3x and not 7x. And also the bigger number is on the bigger product. This is 6x and this is 3x. So it's not worth switching the signs actually. Let's just switch the numbers. Okay, so this was 1 and 3. Let's try 3 and 1 and see if that makes any difference. 3 and 1. Okay, so now we've got, oh, did I not switch the signs? Must not have switched the signs. Yeah, did not switch did not switch them. 1 and 3. 1 and 3. Has this ever happened to you? 1 and 3. I think I got it this time. So this becomes -9x, and this is 2x. Oh, that looks pretty good because that would give us -7x. And so now all we really need to do is flip the signs on this, and I think we'll have it, right? Let's try that. So this was plus and minus. Let's make it minus n plus. So this is 6x squared. This is still negative 3. This is positive 9x. And this is negative 2x. Great. And that does give us positive 7x. So this should be our factored format. Let's try it. Oh, there it is. So good. All right. You can do the same sort of thing with this. Try it on your own if you like. Pull out a negative 1 if you're not sure where to go first. And so this would be 3x squared plus 17x plus 10. All right, leave the negative 1 out there and then start breaking things apart into binomial packets. This is nice because it's plus and plus, so this is going to be plus and plus. Everything's positive. Are you sure? Positive. This is 3x, so the only way to do this is with 3x and x. And then we have to fuss with the 10. Oh, good. A third time. Third time's the charm. Spinning wheel of death. Thank you. I'd like to do some math here. Waiting for you, sweetheart. There you go. Okay. So then the 10 can either be 1 and 10. Unlikely, since this is sort of an average number, could be 2 and 5. So I'm going to try 2 and 5. And so this would give us the 3x squared we're looking for. This would give us the 10 we're looking for. This gives us 3x. Oh, sorry. This gives us 15x. Not you. Oh, and this gives us 2x. Yay. So we got it right the first time. Great. We didn't have to switch anything around because 15x and 2x gives us 17x. So that should be our final form. Whew! Basically, it's a lot of trial and error. Once you try a couple of them and see some patterns, it'll get faster. So give it a shot. Look at the answers to help guide you, but don't use them as a crutch. Okay? We're doing a bunch of them just because I'd like you to try a bunch of them. Everyone's a little bit different, but you'll see some patterns. Okay? Give it a shot, and we'll